Sound. Sound is working.
Check 1, 2. Sorry, my throat's like dead.
Okay. I assume no explanation is necessary to indicate the importance of this document. So.
Yes.
Yes, they named them the Golden Notes. So, quite proud. Well, like best I could do, you know. I guess I could have done golden up. I thought it would show better on yellow. So. Okay, quite proud of this actually. This took a long, long time to create. It started out much smaller, and then over the years I've added things and squished and pushed and pulled, and so it's pretty much everything you have learned all year long.
I don't.
Summarized. So the front side has kind of sections to it. So, like for example, up here in the right, top right, this is just a compact version of the green rule sheet I gave you for antiderivatives. Down the left side is the compact version of the blue rule sheet I gave you for derivatives. Right here, just some quick notes like different ways that we have found the value of integrals, antiderivatives. This little block is mostly just different ways of viewing the fundamental theorem, mean value theorem, and some things associated with finding average rate of change. If you go down to this corner, this is the formulas we did for finding volume, relative max, which means relative min, min-max theorem. The SASE method, which we learned last time, is listed here. Yeah. Okay. The backside I'm particularly fond of. Here's why. When you do FRQs, when you do FRQs, you often have to give a reason for something, and I personally, even as a teacher who does it all the time, I struggle to remember, well, what kind of wording is acceptable? So what I did is I went over lots and lots of FRQs and found several examples of appropriate wording for different situations, and that's pretty much what's on the back. So any FRQ where you're like, oh, how do I write this so that they'll give me the points, just look on the back, it gives a good example. Okay? Questions? Okay. So that's the golden notes. That's yours to keep. Okay, as I mentioned, there is no more homework for term 3. In fact, there is not going to be any more of these style of packets where we like learn a concept, talk about it during class, and then send you home to practice that concept. This is done. Okay? From this point forward, everything we do is AP practice. There will be things that are assigned to be done at home, but it won't be like a regular kind of homework packet. Okay, your first assignment is as follows. This is what's known as the scoring guide for the 2003 test. It gives the questions that were given in 2003, and then it also shows the solutions, although sometimes the solutions are not easy to follow. Most of the time it's fairly straightforward, so it's a little tough, so I'll help with that. It also shows how points are awarded for each question, okay? I compared this to the 2018 FRQ, the one that was given last year. This one is a good match still. Like, it's not so old. I mean, it's 15 years ago, but it's very similar as far as the concepts that they're testing you on, the difficulty level, that sort of thing. So this is a really good place to start. Okay. Now, quick story. And I only share the story if you really will look at me, because it's the kind of story that is not worth sharing if people don't pay attention. Like, you understand that, like, there are experiences you've had in your life that have significance, and if you try to share the story with someone who's not listening, you quickly say, this isn't worth me sharing. Fair? Because they're not sensing the significance. About I lose track of time. I've had too many students. About 4 or 5 years ago, I had a student. Her sister is in my class this year. So her name was Leandra Gibson, and she knows I tell this story, so she's okay with it. But we got ready to do this exact thing, right? Like start practicing for the AP test. And that year, I did it a little different. I started out by giving some multiple choice practice, and then we said, okay, this is our first FRQ practice test. And I passed out to everyone a blank test, so no answers, they'd never seen it before. And the instructions were, be honest, go home, spend exactly 90 minutes. That's the time limit for the FRQ section. Do the best you can. If you come back and you only earn 10 points, it's okay. Like, we're just getting started. There are 54 points possible, and we're trying to kind of move up this scale. Okay? 24 is roughly equivalent to a 3. These might be off a little bit, I'll double check. 30 is roughly equivalent to a 4, etc. So the instructions were, it's your first practice test. If you get 10 or 15, it's okay, don't worry about it. Just do the best you can. Okay, came back to class, we had everyone grade their own that day. Then I kind of go check your score, write it down, right? Okay, Leandra, she didn't give me a score, so I wasn't quite sure if she hadn't done it or whatever. But she came to my desk after class, and she explained. She says, I spent 90 minutes. Like, I was all by myself. I tried as hard as I could to remember what I could remember, and when I couldn't answer a question, I would read the next question. I kept moving. I went through that test several times. I could not think of a single thing to write. Nothing. Like, just, I'm blank. I don't know what to do. Now, to her credit, she was not only battling the difficulty of calculus and trying to put it all together at the end of the year, she's also battling a traumatic brain injury. She had suffered during the year on the drill team. Okay, she really hit her head really hard on the ground, on the floor. So anyway, but I asked her just a simple question. I said, really, with your health situation, if you feel like this is just too much, it's totally fine if you're like, I'm just not going to be able to take the test. But if you really want to take the test, I want to help you. And her choice was, I want to succeed. Just tell me what I can do. I really am feeling lost. So what I had her do is what I'm going to have you do as a start, because it worked so well for her. So our first experience with an FRQ full test, you've never done this, I'm going to give you the scoring guide. We're going to spend today and Friday talking about as much of this as you want to talk about. Okay? Warning. As I've said all year long, if you try to memorize it, it won't work well. Okay? If you make sense of it, then memorize what you made sense of, that works really well. This is what Leandra did. I sent her home to study it on her own. I didn't work with her one-on-one. I just didn't have the time. There's too many students. Then I had her come back, like the next day, after she'd studied it, and I had her do the test again, just from memory, without looking at anything, right? Didn't do great, but made some progress. Like, she's getting some stuff on the paper now, right? Okay, the key point of this story is she started at 0, literally. And over about a month's time, just kind of little by little, day by day. It doesn't happen instantly, but she worked at it little by little. She got to the point that when she took the AP test on May 9th or something that year, she passed. Okay, so she went from 0 to passing in like a month. And she had done what she needed to do all year as well. But so I just tell you that as we start practicing, don't overstress with where you start. That's not that important. What's important is what do you do as you work along. So your first assignment is what I assigned her to do. We're going to study this. When you come to class on Wednesday, it'll be the first test for term 4. Okay? I will give you the FRQ packet, put up the dividers, and you have 90 minutes, well, 85 because class is a little bit short, to just fill out the packet as best you can. Again, go ahead.
When was this, you say?
So Wednesday. So we'll study this today. We'll study it on Friday. You don't have class on Monday. And so Wednesday is the day that we'll take our first practice test. And yeah, it's not realistic because you will have been given the answers first, but it's a really good place to start. Okay, just getting used to the whole idea of how the FRQ section works. Questions? Okay, we're done with tickets because term 3 is over. We are migrating to the Pebbles. We might tell the Pebble story today. We might wait till next time. We'll see what happens. But still keep track of your tally marks. We just pay in Pebbles instead. If you like extra credit, I believe the record for extra credit is something on the order of 26%.
Oh my. I'm beating that.
Okay? And I'm not kidding.
You imagine if I got
I'm not kidding.
bring me an F 2 up.
Yeah, term 4, I treat term 4 differently. Like you've worked, in my opinion, harder in this class to understand, to get where you're at, than you will have worked in nearly any other high school class you will ever take.
Oh, 100%.
Okay? I had a kid one year, he told me he was taking 9 AP classes, and he had to drop this one because he's like, I'm spending more time in this one than the other 8.
Combined?
So he finally combined. So he finally dropped about January. He's like, I can't keep up, and this one's taking the most time. So anyway, that's why term 4 is different for my class. Okay, it's a huge amount of extra credit available if you want to earn it. So
26%. I'm trying to think.
that was about the records.
I can get that.
Yeah.
I can get 26%.
Yeah, the pebbles count. Every pebble counts as, let's see, 100 pebbles is 1% on your grade. So this student had literally like 2,600 pebbles.
Oh my God.
So, yeah.
Did this kid even need that extra credit though?
So
That's
he
the
got a
question.
5 on the test. So
Yeah, but like, was this kid like already at 100% and then he got the additional 26%?
pretty much.
Oh my God. I literally hate this. This is bad.
Okay. He earned it from an activity that I'm not good at creative names. I hate super corny names, you know. So I just call this activity the game.
That sounds so
So-
Well, my playlist is called Stuff.
There you go. Yeah. So he just like, I've had this happen to several students over the years. They just get addicted to the game. Like it just is such a good feeling that they just keep coming. And that's how you're in 2,600 pebbles. So yeah, it's nuts. So anyway, we'll talk a little
What was the
about that.
percent before that? Top percent.
There have been several years where people hit like 1,800, 2,000. So, you know, like I kept one jar because this student was very memorable. She got a 5 and just worked super hard. And she was very addicted to the game. She would just come all the time. And so when she turned in her pebbles, she didn't need them. But I just didn't have the heart to dump it out, and maybe someday I will. But so Shannon Christiansen was the proud owner of that vessel of hope. So, yeah, we do. It's the game, and you have to have a vessel of hope. So, hey, here we go. So let's talk about this. So grab your packet. You can ask as many things as you want. You can take as many notes as you want. But when you take the test on Wednesday, it's all coming out of your head. So here we go. Okay, the first FRQ problem is really quite recent. This was in a very recent homework packet. The area problem came from Unit 4, but the 2 volume questions were on like a packet 2 homeworks ago. So this is very recent. They give this information about the region. They say find the area. So you would just, make note of this is how we kind of talked about doing it. So I'd say f of x is root x. I'd say g of x is e to the negative 3x. To find area, I just take the top minus the bottom. So that's going to be f of x, subtract g. That will compute the length of one rectangle. I multiply that by dx, I get the area of one rectangle. If I integrate from, I'd have to find what b is equal to, so you make sure you find that. Find the correct decimal answer, which turns out to be 0.443. I'd get 3 points for doing that. Questions? Please do.
So on this, they have like E and S for B.
Let me get that in front of me 1 second. If you hold on to the pen. 1 second, I just have to see it. Hold on. There it is. Now it's on the wrong screen. Hold on. Okay, the notation they're using is different than the notation I'm using. Either one is fine, Hayden, so you don't have to write the way they're writing it.
So like, we could just write T equals 0.238.
They'd be totally fine. They went to the trouble to kind of illustrate that they're finding the intersection. You don't have to. As long as you've listed the value, it's fine. 2 points for Hayden. Anybody else? Cool. So back to here.
Is this a no calculator section?
Oh, my bad. 2 points for Preston. So the first 3 questions on this test are calculator allowed. So 1, 2, and 3, make sure you write it down. 1, 2, and 3 are calculator allowed. 4, 5, and 6 are not.
1, 2, 3, calculator allowed, 4, 5, 6.
Yeah. And as far as timing, you get half the time for the first 3, half the time for the second 3.
How many questions are on this?
There's 6 questions.
And they all have A, B, C.
They mostly have A, B, C, D. Yeah. Sometimes just A, B, and C.
It's a big question.
No, 6 times 4 would be 24.
I was like, it was an exaggeration. This is
Okay. When we take the test in class on Wednesday, we will be timed, and it'll be a little bit shorter because class is just shorter, but you've also been prepped with the answers. So we'll probably actually practice the FRQs that same way, like in class, where the time is just a little bit shorter than what you actually get. That, again, should help you be better prepared for the actual test, because we'll be doing just a slightly shorter time period. So, questions there? Okay, next one, B. So part B, again, is straight off the homework from a couple of packets ago. It says find the volume of the solid generated when R is revolved about the horizontal line y equal 1. So I drew a line at y equal 1. And then I remember, when it revolves, the slices are circles with a hole in the middle. So every slice looks like this, roughly. But if I kind of put the slice up on the board, the center of the slice would be right there. The center of the slice is always the axis. So one radius, the radius of the cutout is right here. So I drew that in green. The radius of the entire slice would be from here all the way to here. So that's the pink. Questions? Okay, it doesn't matter what calculus problem I'm solving, what math problem I'm solving. If I have a vertical line and I need the length, it's always y at the top, subtract y at the bottom.
Say that one more time.
So it doesn't matter what math problem you're solving, any class. If you have a vertical line, and you want to know how long it is, y at the top, subtract y at the bottom. So the y at the top is 1. And for this little green line, the y at the bottom would be whatever value f has at that point. The pink's going to be 1, subtract g. Questions to there? So then, I need to find area of this circle. Let's get a different one to hold on to. It's easier. So I've got this circle I'm trying to find the area of. So I take pi times the radius of the big circle squared. Then I take away the middle. So this is my computation for the brown area. Multiply that by dx, that's the thickness. That gives me the volume of one slice. Questions to there? I want to find the volume of all the slices. I integrate. The way points are awarded, you get 2 points for this information. You get 1 point if you have the correct decimal answer.
And this is calculated,
So you would type it in your calculator. Question? Okay, part C. It says this is the region R is the base of a solid. For this solid, each cross section, which means slice, is a rectangle. So now you have something like this. The rectangles sit on the region like this. So I need to find the area of the slice. So the length of this line is just f subtract g. And it tells me that this dimension's 5 times this dimension. So I wrote that down, 5 multiplied by that same dimension. So this is one side of the rectangle multiplied by the longer side of the rectangle. Questions to there? That's how you find this area. Cool. Multiply by dx to get the volume of one slice. Integrate to do it for all the slices. This is how points are awarded. Question? Please, Maya.
There, I said it's the longer side.
You're good. So are you comfortable that to find the volume, we've got to visualize what the slice looks like? Okay. Because the slice has this shape, except that it's significantly longer. So it's this exact shape, but more this way. Because it tells me that every slice is a rectangle. No, you're good. You good? 2 points, please.
Do you have to simplify it to the 5 after that?
You do not. No, if you leave it like this, full credit.
Full credit?
Yep. Somebody last period asked if they could go to here, and I said, yep, absolutely, but either one of these would give you the 2 points.
And then just solve.
Correct. As long as you have the calculator value, you get the 3rd point. Make sure you always round to 3 decimals. Awesome. Next one, number 2. Okay, number 2, also a pretty familiar concept. We worked on this a lot in Unit 4. It says a particle moves along the x-axis, so its velocity is given by that formula. At time equals 0, the particle is at position 1. Go to part A. So I would have written down x of 0 equals 1. That's what they mean by position. Okay, huge key to success on the AP test. Do one thing at a time. One. There are this many points available in the FRQ section. You only need this many to get the maximum amount of college credit available. Okay? It means you can lose 24 points. Okay? No, really. So don't try to do multiple things. Just 1 point at a time. So right here it says find the acceleration of the particle at time equal 2. I stop. I don't keep reading. I just do that. I remember acceleration is the derivative of the velocity. So I have to write this on my paper so the grader can see I'm finding the derivative. But the rest I just do in my calculator. So that's it. That's 1 point. Questions?
Because this is a calculator problem, you have to like write it out.
Yeah, nothing else needs to be written.
So that would be using like the math 8.
Yes.
So you can-
Yeah, I have this in my Y1 register, my Y1 listing or register, whatever.
Yeah.
Math 8, Y1.
So and t equals 2. Or,
Say again.
Like x equals 2.
Exactly. 2 points for Brennan. Anybody else? Awesome. Okay. Then it says, is the speed of the particle increasing at time equal to? Why or why not? Just to kind of help you get familiar with the golden notes. So it can help you remember everything you've learned this year. There's a little reminder right down here on the left. If velocity and acceleration have the same sign, the speed is increasing. I didn't write the other cases because I felt like once you see that, your brain will go, oh, that's right. If the signs are different, speed increases. Pretty good? Cool. So come back here, and I simply have to write that information. So, 1 second. So I find the velocity using my calculator again, and then I give the reason. And that's sufficient.
And to find velocity, you just plug 2 into the
Correct.
equation.
Because they give me the equation that will, I can use this to find the velocity at any time. I just get the velocity when t is 2. And on your calculator, super easy. Because the way we learned it was we put this in y1. And so when you want to find the velocity at time 2, you just do y1, 2. And y1 parentheses 2.
So are like the shortened versions usually acceptable, like cos, neg?
The ones that I show you are acceptable. I try to not show anything that would not be. So I'm pretty careful about that. Like I've just studied a lot of example tests, and these are kind of abbreviations are always acceptable.
Wait, so you find the acceleration by taking the derivative of velocity?
Correct. No, you're good. And with the calculator, you can just do it on the calculator. 2 points for Avery and for Nathan. Cool. Okay. Oh, and then again, you're probably different, but I always struggle. As many times I've gone through the AP test, whenever they say give a reason, I just can't quite remember a good way to word it. So that's why I gave you on the back of the golden notes lots of examples. So like notice here it says a particle moves along the x-axis. So all of these boxes are little explanations that are related to this type of question. So the one we just answered was right, where is it? Right here. You show the velocity, you show the acceleration, and you're right. Since A of 3 and B of 3 have the same signs, the speed is increasing. And I've double-checked these against actual tests to verify that they are reasonable ways to give explanations. Okay, back to here. Part B says, find all times in the open intervals, 0 to 3, when the particle changes direction. So I've memorized this fact. It's on the golden notes, right here. Particle moving along the x-axis. Here it is. At time equal, this is just an example. At time equal 3 seconds, the velocity changes sign. So the particle changes direction at that time. So all we're looking for is when the velocity changes positive to negative or vice versa, the particle changes direction. Questions? Please. So they're asking for, when does the particle change direction? The direction of the particle's movement is controlled exclusively by the velocity. So if velocity is positive, particle's going right.
So you can just graph it though.
Negative, going left. So I just look at the velocity plot on my calculator, right there, and I say, oh look, for all of this time, the velocity is negative. The particle's going that way. For this time, the velocity is positive, particle's going that way. And then the explanation can follow exactly what you saw in the golden note. So right here, the time is the only thing that's different, Cambry. So you'll use your calculator, you find that the time is 2.507, and then just copy this word for word.
So if I don't do word for word, it's kind of just like off.
Oh, as long as it has the same meaning, you're fine. Yeah, you don't have to worry about word for word. Just
Yo dog.
Yo dog, that's good. No, whatever. Okay. Question. Next one. So we got that done. Part C. Part C says find the total distance traveled by the particle. So golden notes again, look. Front side, left, lower left, two key equations right here. Two key equations right here in the lower left. To find the total distance traveled by a particle, we just integrate the absolute value of the velocity.
I remember this stuff.
It comes back better than you think. It really does.
I think it's like a D minus.
No, that's because you didn't do 5 homework.
Yeah, I know. But even with them, probably like a C minus.
Little by little. It's all about the detail. Good here? Now, the detail thing is interesting. Like that sound level meter, you can go to like online, Amazon or whatever, and you can buy a sound level meter. I'm pretty confident for about $40. Okay? The key is the details. That sound level meter, $4,000. Because of the details, okay? The one that costs $40 can measure sound, kind of, but not like that one can. So. Here we good? So back to here.
$20, $20,
Looking it up.
$200.
Questions on this one? Put your phone down, press. Questions here? Are we good?
Yes.
Part D. Okay, look, all you have to do is tell the story. If you look at the velocity graph, we already talked about how the particle is moving left, so I'm just going to tell the grader that, because this is I have to show my work. So I say, for this time period, particle moves left because the velocity is negative. They told me the particle started right here, and it's moving left for the first 2.5 seconds. Well, this little note on the golden notes, right here, says that if I integrate velocity alone, I find displacement. So I'm going to do that. So I integrate the velocity. That turns out to be -3. So the particle was here, and over the next 2.5 seconds it went left. And its position will change by this amount. So it's 1, 2, 3, negative. So because it started at 1, I add that on, and I find out where it's now located. And we need to talk more about that. That's just the fundamental theorem. So, questions? Please.
So you add 1 because that's where it was at time 0?
Right, because the integral of the velocity will never tell you the position. It only tells you how much the position changed. So like the particle was somewhere, 1, in 2.5 seconds, the position of the particle becomes this much more negative. So now I combine those two pieces of information to see where the particle now is located. Like it was here at 1, I go 1, 2, 3, that's about -2. So 2 for Noah. Anybody else? Awesome. So I know the particle was here. It's now here. Let's finish this one. Now the velocity is positive, so I'd write that on my paper. So I'd say, let's see, for t equal 2.507 to t equal 3, v of t is positive, so particle moves right.
Do you need to put both of them? Isn't it just asking for the farthest one to the left or to the right?
It's said to show my work, so I kind of feel like I should mention this, that I'm keeping track of which way the particle's moving.
Like, technically you don't really have to because it's just asking you.
It's asking, where is the particle farthest from the origin?
So like if I just found one or the other, if I find both and then just write down one.
I think you'd be okay on this one because it didn't say you had to justify your work. So then I go say the position at time 3 is going to equal 1 plus the integral from 0 to 3 of the velocity. I work that out. I don't have that number in front of me, but whatever that happens to be, I then just look at the 3 numbers. The particle was here, it went left for a while, came back right for a while. Whichever those numbers is greatest, absolute value, that's going to be when the particle is farthest from the origin. Please.
Sorry, so like on B, I see that says square root of 2 pi. Like, would we do B, or we just look at the graph and look at where the change is direction? Can we just like, say like, calculate 0 and find that?
Hold on. So you're looking at.
Like for B, you just look at the graph, right?
Yeah, you don't have to do the root 2 thing. Is that what you meant?
Yeah, can I just calculate 0?
Correct. They did it by hand. Like they did it without their calculator. You don't have to do that.
Okay.
You can just find that the value is 2.507, just using your calculator. Boy, please, Wes.
For part C, you did like +1 in the beginning, you know?
Part C?
Yeah, I mean, in the, I don't know, maybe I got confused.
You're okay, let's keep talking.
You said it's the x, 2.507 equals 1 plus.
For this one here.
Yeah, is that for part C?
Part D.
Oh.
No worries. Point. Anybody else? Please.
You asked about like the greatest distance of the particle to origin. We always check its initial position, and then when it changes direction.
Yeah, listen to Maddie. That's the key. Hey, no, it's very good. Particle is how far from the origin here? Just say it. 1. Particle is going to go left. So I need to know, well, where does it end up after moving left for a while? Because that could be farther than 1. And it was 2.2 from the origin.
Origin's always 0, right?
Origin is always location 0. So now it's going to go right. So I do that computation. I don't have this done. I'll have to work that out. But
do we find where it changes direction looking at the graph where it's positive or negative?
I pay attention to the velocity. Be careful. Make sure you're looking at velocity. When the velocity is negative, the particle's moving left. When the velocity is positive, the particle's moving left.
Moving right. So for an FRQ, that's where we look to find.
Anybody else? Cool. Okay. We're going to finish the day with another part of the game. So I'll explain the game later, but basically I'll explain later. But after a good solid 2-hour session of the game after school, we also have a great tradition in this room.
Of crying.
Of crying? No. The game is like none other. I need to break out some video. I don't have any video. Yeah, I have some video of the game. It's not crying. No.
I'll be screaming.
No. The game is celebration. It's hard work, yeah. But we always end the game with a music quiz before we go home. Oh, yeah. The most memorable music quiz I've had, well, I'm not going to say most, I've had several. One very memorable music quiz was the room has, like I swear, 50 people in it. True story. Like we start playing the music quiz, people are so into it. They turn off the lights, they got their cell phones on. Like Braden Bromley's like dancing in the front. And it's good times. So we'll have a quick music quiz.
Oh, mother, I'm so
I did 10
I was, we were like joking.